students. In this session, let us know about the velocity analysis by using the Instantaneous center method. So already we have covered the relative velocity method. So next to it, let us discuss about the Instantaneous center method to do the velocity analysis. So for our consideration, consider a rigid link AB. Now at its initial position, it is at AB and it attains a final position A1, B1 by two different types of motion, one translation and another is rotation. So first by translation, it attains a position A1, B dash, and by rotation, it attains the final position A1, B1. Now, for our analysis, to reduce the difficulty of the analysis and to ease the calculation, let us assume that in the link is attaining the final position by only per pure rolling, that is rotation. So it is assumed that the link attains the final position A1, B1 by rotation only. So based on this assumption, the method is carried out. So the link AB attains the final position only by rotation. So the link is rotating attains the final position A1, B1 by a center called the instantaneous center. So it is assumed that with the instantaneous center of rotation, the link AB attains the final position A1, B1. Here in the instantaneous center is applicable only at that instant only, and the next instant in the location of the center changes. So it is changing continuously. Now for the attaining the final position, the link gradually attaining the final position. So we get the various center of rotation, instantaneous center of rotation. Now we get the various points. Now we join all the points, we get the locus of the points. In the locus of the point, there is a curve is called a centroid. So by this explanation, let us know the definition of the instantaneous center of rotation. So the instantaneous center of rotation is an imaginary point about which at any instant the link is assumed to be rotating, because the two motions are combined to one motion, that is rotation, with the help of a center called the instantaneous center of rotation. Its other name is virtual center of rotation. Okay. Next. Now consider the same link AB. Now the direction of the point A is vertically upwards, VA, and let us assume the velocity of the point B is horizontal. Now we know the direction of the both points. Now we can erect a perpendicular to the both directional velocities. So the both perpendicular lines meet at a point called I. So it is a instantaneous center at this instant for the link AB. Formally, the velocity of the instantaneous center is 0. For this, we know the procedure for drawing the velocity triangle. Now fix a fixed point O, that is origin. Now you draw the velocity for the A and B. Now the OB vector represent the velocity of the B and OA vector represent the velocity of A. Then AB is the velocity of B with respect to A. Now by looking the diagram, we get the two triangles AIB and AOB. Now from the two similar triangles, we can get some similarity. Now by equations velocity of point B on the link, we know the formula is omega into r. So the link is rotating at uniform angular speed omega. So the velocity of point B equal to omega into r. Here the B is rotating at that instant from the center I. So the distance R here represents IB. Similarly, for the point A on the link AB, B equal to omega into R. Omega into R. So here R represents the distance of Instantaneous center from the respective point IA. Now from the two equation, the omega can be solved. Here the VB by IB equal to BA by IA equal to omega. So the velocity of point B can be written in the vectorial form OB. Similarly, for the velocity of A point is rewritten as OA. So from this relation, we can calculate the angular speed and also from other unknown parameters from the known parameters. Now let's consider the four link. Here the link one is fixed. Now there are some three types of instantaneous center. One is the fixed permanent instantaneous center. Second is the fixed instantaneous center. Third is the neither fixed nor permanent instantaneous center. Now the link one is fixed. So here at the junction of 1,4, because all the links are pin jointed. So for this configuration, the instantaneous front of rotation lies in the at the center of the pin. Here the link 1,4 now the I-14 is always permanent because the link one is fixed. So at all configuration of the mechanism, the I-14 lies here only. Similarly, I-12. Now consider the center I-34 and I-23. These are located at the junction of 3 and 4 and 3 and 2 respectively. Here, for various configuration, in the location and the position of I-34 and I-23 are changing, but all the links are connected by a pin. So the pin is permanently joins the two links 3 and 4 and the 3 and 2. So the I-34 and I-23, even though they are changing from different location, they are called fixed permanent instantaneous center. Now I-13 and I-24. The I-13 is common to link 1 and 3 and I-24 is common to link 2 and 4. The two instantaneous centers are called neither fixed and nor permanent instantaneous center because for various configuration, this location are changing continuously. So these are neither fixed and nor permanent instantaneous center. Now let us discuss about the method for locating the instantaneous center in a mechanism. First, for the mechanism given, now we have to determine the number of instantaneous center by using the simple formula n into n minus 1 divided by 2. Here the small n represent the number of links. For 4 links, we know the number of instantaneous center is 6. Next is to locate or draw the bookkeeping table. Here the links for our consideration, there are 4 links. Then instantaneous center. So we have to write various combination of the instantaneous center possible. We know already the number of instantaneous is 6. So 1, 2, 1, 3, 1, 4, 2, 3, 2, 4, 3, 4. So there are 6 instantaneous center. Next, the locate the first 2 types of instantaneous center, that is fixed and permanent instantaneous center. So from this diagram, we can easily locate I-14, I-12 and I-34, I-23. Next job So on locating the 3-4 centers, you have the tick mark on the bookkeeping table. Now the next step is to locate the I13 and I24. So these centers are located with the help of a circle diagram. Now let us draw a circle of any radius and to draw a square and mark 1, 2, 3, 4 for the 4 links. Here in between 1 and 2, you write the I12 and between 2, 3, I23, here I34 and I14. So there 4 incident center. Next, we can find the I13. Let us locate the I13. Next is task is. So for I13, you join 1 and 3 with a dashed line. Here, the 1-3 line forms a 2 triangle 1, 2, 3 and 1, 3, 4. So the line 1, 3 is a common side for the 2 triangles 1, 2, 3 and 1, 3, 4. Here we can easily know the I13 incident center is located at the junction of the 2 pairs of the incident center I12, I23 and I23 and I14. Okay, so the I13 is located at the junction of the 2 pairs of incident center I12 and I23 and I23 and I14. Here from the diagram, here I13. So at the junction of I14, I34 and I12, I23. So we can extend the line from the mechanism, both adjoin its at the one point, it called I13. Similarly, I24 can be located. So from this circle diagram, the last 2 incident center can be located. So in the next session, let us practice here a problem to find the velocity by using this incident center method.